Running a cable in polyvinyl chloride or PVC coated conduit does not render the cable fireproof. While it offers a degree of protection against fire damage, it's crucial to understand its limitations. The PVC coating acts as an insulator, which can help prevent the cable from overheating. Overheating is a significant factor that contributes to the risk of a fire starting. The National Electrical Code, or NEC, doesn't specifically address the fire resistance of PVC-coated conduit directly. However, the NEC mandates that all electrical wiring must be installed in a manner that minimizes the risk of fire. This overarching requirement includes the use of conduit to protect cables from mechanical damage and from contact with other flammable materials. Using conduit is a preventative measure intended to enhance safety. PVC-coated conduit is a suitable choice for protecting cables in environments where a fire risk exists. Nevertheless, it's vital to recognize that no conduit is entirely fireproof. Under intense fire conditions, the PVC material can melt or burn. This could potentially compromise the integrity of the conduit and lead to damage to the cables housed within. Several factors influence the fire resistance of electrical systems. These include the type of materials used, the installation methods employed, and the overall environmental conditions. Firstly, the type of materials plays a critical role. Different materials exhibit varying degrees of fire resistance. For example, steel conduit generally offers better fire protection compared to PVC conduit due to steel's higher melting point and non-combustible nature. Cable insulation materials also vary widely in their ability to withstand high temperatures and flame exposure. Secondly, proper installation methods are crucial. Ensuring that conduit is correctly supported, sealed, and grounded can significantly enhance its fire resistance. Poorly installed conduit may create pathways for fire to spread, increasing the risk of damage to the electrical system and surrounding structures. Thirdly, environmental conditions can affect fire resistance. Exposure to moisture, chemicals, or extreme temperatures can degrade conduit and cable insulation over time, reducing their ability to withstand fire. Regular inspection and maintenance are essential to identify and address any potential issues before they compromise fire safety. Furthermore, the NEC provides guidelines for selecting appropriate wiring methods and materials based on specific occupancy types and environmental conditions. For instance, Article 300.4 F of the NEC addresses protection against physical damage, which can indirectly impact fire resistance by preventing damage to conductors that could lead to electrical faults and fires. Similarly, Article 310 of the NEC outlines requirements for conductor ampacity, ensuring that conductors are not overloaded, which can cause overheating and increase the risk of fire. When evaluating the fire resistance of PVC-coated conduit, consider the following points. 1. PVC is a thermoplastic material, meaning it softens and melts at elevated temperatures. While it can provide some insulation and delay the spread of fire, it is not inherently fireproof. 2. The thickness of the PVC coating can influence its fire resistance. Thicker coatings generally offer better protection compared to thinner coatings. 3. The presence of flame retardant additives in the PVC compound can enhance its fire resistance. However, even with these additives, PVC will still burn under sustained fire conditions. 4. The type of cable installed inside the conduit also affects the overall fire resistance of the system. Cables with high temperature ratings and better insulation materials will offer greater protection against fire damage. In addition to conduit and cable selection, other fire protection measures can be implemented to enhance the safety of electrical systems. These include installing fire stops to prevent the spread of fire through walls and floors, using fire-resistant cable trays to support and protect cable runs, and implementing fire detection and suppression systems to quickly detect and extinguish fires. It's important to consult with qualified electrical engineers and fire protection professionals to determine the appropriate fire protection measures for specific applications. They can assess the fire risks, evaluate the available options, and recommend solutions that meet the applicable codes and standards. Understanding the limitations of PVC-coated conduit and implementing comprehensive fire protection measures are essential for ensuring the safety of electrical systems and protecting people and property from the dangers of fire. Remember that relying solely on PVC-coated conduit as a fireproof solution is not sufficient. A holistic approach that incorporates multiple layers of protection is necessary to mitigate fire risks effectively. This holistic approach also includes things such as regular inspections. Regular inspections are very important. The NEC, while not explicitly stating that PVC-coated conduit is fireproof, provides numerous articles and sections that indirectly address fire safety through requirements for wiring methods, overcurrent protection, grounding, and equipment installation. For example, Article 230 of the NEC covers service entrances, which are critical points for electrical systems. Proper installation and protection of service entrance conductors are essential to prevent fire hazards. Similarly, Article 240 of the NEC deals with overcurrent protection, such as circuit breakers and fuses, which are designed to interrupt the flow of electricity in the event of an overload or short circuit, thereby preventing overheating and potential fires. Article 250 of the NEC focuses on grounding and bonding, which are crucial for providing a safe path for fault currents to return to the source, reducing the risk of electrical shock and fire. Article 300 of the NEC provides general requirements for wiring methods and materials, emphasizing the need for proper installation and protection of conductors. Article 310 of the NEC covers conductors for general wiring, including ampacity ratings and installation requirements. Selecting the correct conductor size and insulation type is vital to prevent overheating and fire hazards. Furthermore, the NEC includes specific requirements for different types of occupancies and environments, such as hazardous locations, healthcare facilities, and commercial buildings. These requirements address the unique fire risks associated with each type of occupancy and specify additional safety measures to mitigate those risks. For instance, Article 500 of the NEC covers hazardous locations, which are areas where flammable gases, vapors, or dust may be present. In these locations, special wiring methods and equipment are required to prevent explosions and fires. Article 517 of the NEC addresses healthcare facilities, where the reliability of electrical systems is critical for patient safety. This article includes requirements for emergency power systems, isolated power systems, and grounding to minimize the risk of electrical shock and fire. Article 518 of the NEC covers places of assembly, such as theaters and auditoriums, where large numbers of people may be present. These locations require additional fire safety measures, such as emergency lighting and fire alarm systems. Beyond the NEC, other codes and standards, such as those published by the National Fire Protection Association, or NFPA, also provide guidance on fire safety in electrical systems. NFPA 70E, for example, addresses electrical safety in the workplace, including requirements for arc flash protection. NFPA 101, the Life Safety Code, provides requirements for building construction, egress, and fire protection systems to ensure the safety of occupants in the event of a fire. NFPA 13, the standard for the installation of sprinkler systems, provides requirements for the design and installation of automatic sprinkler systems, which are an effective means of suppressing fires and protecting property. Therefore, to effectively protect cables and conduit from fire, consider a multifaceted approach. 1. Use metal conduit such as steel or aluminum. These materials offer superior fire resistance compared to PVC. 2. Select cables with high temperature insulation ratings. Cables designed to withstand higher temperatures will be less likely to ignite or propagate fire. 3. Install fire stops at regular intervals along conduit runs. Fire stops prevent the spread of fire through walls, floors, and ceilings. 4. Use fire-resistant cable coatings or wraps. These coatings provide an additional layer of protection to the cables. 5. Ensure proper grounding and bonding of the electrical system. Proper grounding and bonding help to prevent electrical faults that can lead to fires. 6. Install fire detection and suppression systems. These systems can quickly detect and extinguish fires before they spread. 7. Conduct regular inspections and maintenance of the electrical system. Regular inspections can identify potential fire hazards and ensure that all safety measures are in place. In conclusion, while PVC-coated conduit provides some protection against fire damage by insulating cables and preventing overheating, it is not fireproof. The NEC requires all electrical wiring to be installed in a manner that minimizes the risk of fire, which includes using conduit to protect cables. However, it is essential to consider other factors such as the type of materials used, installation methods, and environmental conditions. Employing a comprehensive approach that incorporates multiple layers of protection is crucial for mitigating fire risks effectively and ensuring the safety of electrical systems. Consulting with qualified professionals and adhering to applicable codes and standards are essential steps in achieving this goal.